All right, guys, Mr. Alent here, looking at our Unit 9, Section 4 notes, which we're going to be looking at some of the properties of logarithms. So last week we introduced logarithms for the first time. Now we're going to learn about some operations, things we're going to be doing with logarithms as far as what are some of their properties. And so the first property that we have is going to be called the product property of logarithms. Again, hopefully you've printed these notes up and you're doing this with me or looking at it with me. And it comes from right up here, actually. Because logarithms are exponents, you can derive the properties of logarithms from the properties of exponents. So remember, when you multiply powers with the same base, you get to add the exponents. For instance, if we had b to the m times b to the n, so the same number b, then what that would be the same as is b to the m plus n. That's no different, guys, than saying like x squared times x cubed, right? We would say that's the same as x to the fifth, right? Which is 2 plus 3, right? That's what we're saying right here. Okay, so because that occurs where you add the exponents, you add 2 and 3 to make the 5, we're going to do something very similar. The logarithm of the product equals the sum of the logarithms of its factors. And so here's the formula right here that says basically log base b of m times n, and that's like in parentheses, like they're both part of this logarithm. That's going to be equal to log base b of m plus log base b of n. And so what it would look like in an example here, log base 3 of 1,000, break up 1,000 into some things that multiply to it, like 10 and 100. So you could rewrite this. This would be equivalent to log base 3 of 10 plus log base 3 of 100. Okay? And by the way, this goes either direction. Okay, it's bidirectional. If I had this, I could go to that. If I had that, I could go to that, right? And that's what we'll see in our first examples here for adding logarithms. I've got log base 4 of 2 plus log base 4 of 32. So because the base is the same, and that's the key, guys, right? The same base, same base, same base, same base, same base, same base, right? Because it's both the base 4. And I'm adding these same bases. What our rule says, if I'm adding same bases, I can just take one logarithm of their product. So this will be equal to the log base 4 of 2 times 32. Okay, which then gets me log base 4 of 64. And then, so kind of question for you, so what is that actually equal to? What is this equal to? You know, if we keep going from last week, what is log base 4 of 64? Well, again, that's 4 to what power gets us 64? And that's to the third. 4 to the third is 64. So log base 4 of 64 is 3. So up here at the stop, at the beginning, log base 4 of 2 plus log base 4 of 32, what is it equal to? It's equal to 3. Crazy, right? There you go. All right, let's do the next one. Log base 1/3 of 27 plus log base 1/3 of 1/9. Again, same base, so I can go ahead and multiply those. So I'll have log base 1/3 of 27 times 1/9. But 27 times 1/9, that's the same as 27 divided by 9, which is 3. So we got log base 1/3 of 3. All right, and what is that equal to? Well, 1/3 to what power gets us 3? That's going to be a -1. It's an inverse, right? So this guy equals -1. If you wanted to see 1/3 raised to what power equals 3? Well, it's a reciprocal. 1/3 becomes 3 because of a reciprocal -1. Okay. And log base 5 of 625 plus log base 5 of 25. Sometimes, you know, if we wanted to do the multiplication, like let's see what we have here real quick. This would be log base 5 of 625 times 25. Well, that's a big number. It's 15,625. And if I was, again, thinking about what is the solution here, 5 to the what equals 15,000 to 625. That's not so easy to mental math, right? I don't know what that is off the top of my head. So sometimes it is easier to not use the property. This comes from our product property. But let's just think about them individually. You know, 5 to what gets me 625. If I just think about that individually. And that's going to be 4. 5 to the 4th is 625. 5 to the what gets me 25. 5 squared is 25. So this is a 4 plus 2, right? 4 plus 2. It's going to get us 6. So there we go. So down here, if we wanted to say, we could say now we know that that's 6. 5 to the 6th is 15,625. So sometimes it's easier to, you know, evaluate the logarithms first and add, and it just depends on the scenario. Okay, let's see another property. This is called the quotient property. Quotient is division. Product is multiply, right? Product is multiply, and that's what we're dealing with, multiplication. Quotient is division. So when I see division, okay, and it's again comes from this, like we talked about. B to the m over b to the n is equal to b to the m minus n. And again, if I put it in terms of x, that'd be like saying what's x to the 4th over x squared. Well, another way you could do that is x to the 4 minus 2, which is x squared, right? 2 of these cancels 2 of those. 4 minus 2 is 2. That's essentially what we're dealing with. And so applying that kind of idea to logarithms, and you get this formula here that says, okay, if I have log base b of two things divided, I can find their logarithms individually and subtract, or vice versa, right? Again, just like before, this is bidirectional. It does go either way. So if I see the same bases of logarithms with a subtraction, I can turn that into division. Okay. So, first example here, express as a single logarithm and simplify if possible. Log base 2 of 32 minus log base 2 of 4. So our property says we have the same base, log base 2. Now we can take them then and do a division, 32 divided by 4. Well, 32 divided by 4 is 8, so this is log base 2 of 8. And we want to know what that equals to. 2 to what power is 8? And that's 2 to the 3rd. All right? Log base 2 of 8 is 3. So our subtraction up here has got to be 3 also, because these are equivalent statements. All right. Log base 7 of 49 minus log base 7 of 7. This is a really good one that's set up nicely because we're doing subtraction, so we're going to divide the 49 and 7. 49 divided by 7 is 7, so we got a log base 7 of 7. 7 to what power gets you 7? It's to the 1st. So if I'm up here, log base 7 of 49 minus log base 7 of 7, that's just 1. Crazy, right? All right, so single expression and evaluate. I guess I should have been boxing these. These are kind of the, right as a single logarithm, there it is. And simplify if possible, there's the 3. Right, if I go back up to these ones, the same idea. We wanted to get to this point. Single logarithm simplified. Single logarithm simplified. Right here. Okay. Let's see. The back side. We got time. Let's go ahead and do the next one, and then we'll save the other two for another video too. So the next one is the power property of logarithms, which says, okay, let's see here. Log base 10 to the 3rd. So notice there's an additional like exponent in here. This guy has this exponent 10 to the 3rd, which is the same as 10 times 10 times 10. And then if we kind of really apply that product rule up here, right? That'd be like saying, okay, so log 10 plus log 10 plus log 10. In other words, I'm doing 3 log 10s. And so what happens is log base b to the a of a to the p, so this additional little exponent in there, that exponent basically like kind of comes in front and it multiplies, right? We had log base 10, common log of 10 to the third became 3 times common log 10. So same here, that p, that exponent, becomes the multiplier in front, the coefficient, if you will, and then no more exponent inside there. Okay, so let's see some of those. So this is now the back side of these notes. See if we can get through these couple pretty quick. All right, so express each as a product and simplify if possible. So here it is. This is an example where this number that we're taking the log base 3 of is raised to this power 2. So what happens is that 2 basically like migrates to the front, and you would say that's the same as 2 times the log base 3 of 81. Right? It says write each as a product and simplify. Well, there's our product, and what's that equal to? Well, log base 3 to 81 is actually 4. This is like 2 times 4, right? Because 3 to what power is 81? 3 to the 4th is 81. So this is 2 times 4, which is going to give us 8. Okay. Let's do that over here. So the power comes down and becomes a multiplier, 3 times log base 5 of 1/5. We want to know what's that equal to. So we've written it as a product, and we're going to simplify. So we're going to have 3 times, okay, so let's see, 5 to what power is 1/5? That's to the negative 1. So 3 times negative 1, that's going to give us a negative 3. Okay. Log base 10, so common log really, probably didn't need the base 10, but common log, 10 to the 4th. So this 4 comes down, right? So we got 4 times log base 10 of 10. So that's 4 times. 10 to what power gets you 10? 1, right? Anything to the first power is itself. So 4 times 1 is 4. Okay, and our last one here, again, the power gets to come down and multiply 2 times log base 5 of 25. We want to know what that equals. Simplify it. 2 times, okay, log base 5 of 25. So 5 to what power is 25? That's 5 squared. Right? 5 squared is 25. So this power is 2. So 2 times 2 is 4. And there we go. Okay, we're going to end this video here. I'll keep going on these notes in our next video, so make sure you go there to finish this off with a couple more properties.